Good afternoon. This is a message to my Finance 217 classes for the spring of 2017. I'm grading your quiz number 1 right now, this one. So I figured I may as well just generate the key right now and explain to you how I come about it. That way you know how to do that stuff. And after all, that's what the quizzes are for, right? Let me share up the screen. Get stuck in the matrix, get rid of the matrix. And depending on which of the two quizzes you had, it was either the, you were either mapping this approximation of data from the New Zealand side or the Australian side of the third ODI from the 2017 Chapel Hadley. If you have Watch ESPN, you can take a look at it. It is a 50 over sort of thing. It's a good little cricket match to watch. Actually, it's pretty exciting. Anyway, so this is a histogram. It doesn't really matter what the data represents, because the X variable is whatever's across the X-axis. In this case, it's the runs scored on each ball. There are a certain number of balls, whether it was for the New Zealand team or for the Australian team. A certain number of balls were hit by each, batted by each team, bowled by each team as well. And you can score anywhere between 0 and 6 runs. You can actually score more than 6 runs, but it rarely happens. And this is not exactly, it comes from the best I could do from the box score and based on some other percentage that's here. Anyway, that's just the state of the data. But here's how I look at grading this. First thing that was asked of you to do in the chart to the left, generate a relative frequency table for the runs scored on each ball. And it needs to be a relative frequency table rather than just a frequency table, because you could, if you had the New Zealand quiz, you could generate a frequency table which looks like this. In other words, 166 balls scored, 0 runs. So X, which is the number of runs scored on each ball, could be 0, 1, 2, 3, 4, 5, or 6. 166 times no runs were scored. 70 times 1 run was scored. 34 times 2 runs. 28 times 4. And 3 times 6s were scored by the New Zealand team. If you had the Australia quiz, this is the frequency distribution, which could be generated from this particular histogram. So depending on the quiz that you had, one side or the other, you would basically generate the same thing, which is starting with a frequency distribution. Control T, it's going to turn this data into a table. Ooh, that's not how I want it to look. Control Z, undo. Actually, this is what I want, so highlight what I want, Control T, boom. Now I have X in this column and F here. In order to generate the relative frequency table, I need to generate relative frequencies. In order to generate relative frequencies, I need to have F over N. Right now, I don't have N. Alt equals will auto sum and tell me that there were 301 balls bowled to the New Zealand side. Over here, if we're looking at Australia, we would see that there were all equals 282 balls bowled to Australia before they were all out and lost to New Zealand, and the trophy goes back to New Zealand. Anyway, we'll start with New Zealand first. We'll just take a look at these. We're a little too close. Now we're back. All I've done here is generate a frequency distribution. In order to get the relative frequencies, I got to take the frequency divided by the total. As percentages, this is what you'll be presented with. But I tend to think of probabilities in terms of 0 to 1 rather than percentage. But P, or P of X, can be probability, proportion, percent, or relative frequency. All of those are the same. 55% or 0.55 is the relative frequency of zeros. They're not no balls, that's different, of zeros. 0.23 represents the proportion of times 1 run was scored on a ball. So this is what your relative frequency table should look like if you had the New Zealand quiz for this particular histogram. If you had the Australia quiz, we would effectively do the same thing, which is P of X. And this is a thing I've gotten a habit of. Turning this Control T into a table means I only have to do this once, and all this gets taken care of. And it's sort of a weird little cheat here. It will float the decimal points here. 154 out of 282 is 0.5461. We can get more or fewer decimal places depending on what the fraction actually rounds to. But rather than trying to, I don't know, do Control Shift 1, I could do that for all of these, Control Shift 1. Yeah. That gets me to putting those into decimal or proportion form. So if you had the New Zealand quiz, this is what your relative frequency distribution should look like. If you had the Australia quiz, this is what your relative frequency distribution should look like. And from there, you can answer the rest of the questions on the quiz. Just a note on grading. If instead of giving me a relative frequency distribution, you gave me a, that's not what I wanted. If you gave me a frequency distribution as opposed to a relative frequency distribution, I can't give you full credit, so I give you half credit there. The way the points are broken out is there are 6 questions at the bottom of the quiz. Each of those are worth 10 points or 10%, and filling in this relative frequency distribution is worth 40% of the quiz. However, I think I've sort of given a bunch of points here that the X column, if you have 0, 1, 2, 3, 4, 5, 6, which is seriously just translating what's on here, that's worth half. And the other half of the 40 points, so 20%, is this column for relative frequencies. If you put absolute frequencies in there, counts, that can only give you half credit. In other words, if this is what you gave me, you get 30% rather than 40%. If you gave me this, you would get full credit for that. And there are little bits depending on your rounding. For example, if this number rather than 0.10 was 0.09 because you rounded funny, I might let that slide. I haven't gotten to all the grading yet. I don't want to bust your chops too much about your ability to round. I want to make sure you can generate the stuff. And besides, the quiz is just you demonstrating to me that you know what the concepts are, but you should still be responsible for accurate computation. So please know that that's the expectation going forward. It's the expectation coming in. It's also the expectation going forward. So the 6 questions that you need to answer based on your relative frequency distribution are as follows. If you have the, correct that, if you have the New Zealand quiz, the variable, the outcome X in the above table is the number of runs scored on each ball. So 1A, the answer is actually what's written here, which is runs scored on each ball. If you put that, you get full credit. If you gave me something to do with runs, but it wasn't exactly what we were after, then, you know, I might have to dock you a couple points. What is the probability that a ball selected at random scores 1 run? So probability, proportion, percent, whatever we're looking at for the relative frequency here, is this row. So if you had the New Zealand quiz, 0.23 or 23%, says round to the nearest whole percent. So that's really what I'm after. But if you gave me 0.23, that's fine. But 23% is the answer. That's the probability or proportion of time that New Zealand scored 1 run. And Australia scored 1 run about 25% of the time. So you can see basically from these 2 shapes, this one or this one, they have roughly the same shape and roughly the same numbers. So you'd imagine they would have roughly the same relative proportions. But if you have New Zealand, it's 23%. If you have Australia, it's 25%. And the next 4 questions were the same for each of them. As we just looked at when we generated these tables, the N, or sample size, for New Zealand was 301 balls. Australia received 282. The mean number of runs scored, rounded to the nearest tenth, we calculate from the relative frequency distribution. So I use the formula X times P of X, and we add it all up. So in this column, I take X times P of X. And that should be decimals, please. All equals, auto sum, and into a decimal, rounded to 2 places. So 0.89 is not what I asked you to round to. Rounding to the nearest tenth means this should round to 0.9. So the answer I'm looking for here for the New Zealand quiz is rounded to the nearest tenth. To B is 0.9. We did it for Australia. X times P of X. X times P of X. All equals 0.91. 0.91. Where are you at? There we go. 0.9 is actually what I'm looking for. Time to calculate the median numbers of runs scored by each team. Well, if there were 300 runs scored by this team, or sorry, 300 balls bowled to this team, 301, what we're looking for is the number of runs scored on the 150th highest ball, or 151st. F11 turns that into, I said, F11 turns this into a chart. That's not the chart I want. The chart I want looks more like 100% stacked bar chart, where this is all 100 or all 301 balls bowled to New Zealand. Notice that there are only 1, 2, 3, 4 X values which have non-zero frequencies, or 5, sorry, I'm gonna include this one. Only 5 which have non-zero frequencies. So if we look at this chart and we see 1, 2, 3, 4, and I'm gonna guess that somewhere above there, we zoom in real close up here, we might be able to see one. You know what, we can't even see it. It's so small. But what we can see is that there were 160. Do we have all these? That's suspicious. Let's double check. It says 0.166, value 70. Oh, because it looks funny there. No, we're good. See, 1, 2, 3. Oh, because it wants to change those variable labels. That's the first one, so it thinks it's 1. It's actually calling that the first one, second, third, and that's the 7th one. And that's why it's giving me weird, and I didn't bother with value labels on here. But regardless, this is, it's not 70. Data table. Now I'm just messing. You should fast forward until I'm back to what you want to look at. I'll get back on topic. This is it's the same stacked bar chart. The labels look a little funny, but there were a frequency of 166 here. 166 balls which scored 0 runs. Here is really what we're after, which is that 50%. If this is 100% or all things, the lowest 50%, 0 runs were scored. But then once we get above that, we're into the top half. This is the bottom half in blue, and this is the top half in a little bit of blue, some orange, some other orange, and some green. So this up here represents the top half, and this is the bottom half. This colored blue comes from these 166 observations where no runs were scored. In other words, the median is 0. The median is 0 because it represents an X value below which half of things fall and above which half of things fall. We would see the very same thing if we were looking at the Australia data. Although it's a little bit more pronounced here. It's about the same. 55% or 55% for New Zealand. Anyway, that's the lowest half and then some. So in both cases, the median is 0. The mode is also 0 because it has the highest relative frequency, which also means it has the highest frequency. But whichever one of these is the highest, the maximum is 154. It means that this blue bar, which is the biggest, also represents the mode. So N was the count, 301 or 284? 282. depending on your quiz. I'll move it through the percents. The mean was 0.9, the median was 0, and the mode was 0. So depending on all that, that's what the answers of the quiz were. And in terms of other points on grading, for other points on grading, there were rounding instructions. If you didn't follow rounding instructions, I may dock you up to 5 or 10% from your quiz grade, but probably more like 5% if your answer is right. Then I don't want to do too much damage there. So that's your quiz.